to you.
Thank you very much. Are you all hearing me clearly?
Yep, perfect.
Yeah. Okay. So this afternoon, I'd like to present our work on the roll-up digital steel pan. Very good afternoon to everyone. And this work is based off ongoing projects we have in my design and innovation group at UTT in the Department of Design and Manufacturing Systems. So the main question we're looking at here is how can we come up with further innovations on the steel pan or based on the steel pan instrument? Right now, there are a range of digital steel pans on offer, and the key issues are they can be quite expensive and also lack portability. So if you look on your screen, you would see various instruments and the costs from left to right. So the traditional steel pan, if you look at the TT cost, will be fairly expensive, a few $1,000s, depending on the model. You have the pan cut, which seems to be out of production. That was a MIDI controller developed. You have the electronic pan. The cost of that is about 22 to 27,000 TT dollars. The PHI developed at UE, percussive harmonic instrument. The cost, as far as I know, the latest information is around 20,000 US. So the question is, well, what about the lower end of the market? What about instruments for, people who can't afford these expensive digital instruments? And also, could we look at developing something that is a little more portable than the current steel pan instrument? The steel pan itself is metal, so it's heavy, it's large, and the digital versions are also quite big. They take up a lot of space. The inspiration then is, could we develop a steel pan type instrument based on the roll-up instruments, the low-cost roll-up instruments that are currently available? So you'll see the digital piano. You have a traditional piano there on your left, but on the right, you see the roll-up version, which I've played around with. It's quite a nice little portable instrument to use for practice, for carrying around, and it generates a reasonable sound. Of course, if you use headphones, you could get better sound quality. Below, you would see a drum kit, a drum set. And again, on the right, you would see the roll-up version, which is basically a simple pad where you would use the drumsticks to play the instrument. So how would such an instrument based on the steel pan look? And most importantly, would musicians want it? So in terms of product development, there's only one key question. It makes no sense building anything that people don't want and would buy or would use. So with any product development exercise, we first need to see if there's a need for the product and if it could be further developed. In our teaching and in our group at UTT, we use the double diamond model for product development, which is a very simple model. A lot of design process models around, but in my mind, this encapsulates the key processes or phases that you need to go through, which comprise discover, define, develop, and deliver, the 4 Ds. So the first 2 phases, discover and define, is what I'm going to talk about a little bit today. And that's whether to ask the question, are we building the right thing? And the second 2 phases, the develop and deliver, really is about, well, are we developing the thing right? Are we making it in a good way for use and manufacturability, etc.? So the idea we came up with is to have a simple interface with the notes laid out on the steel pan, just like the steel pan on this circular fifths layout. So the idea here is that the base layer is flexible and the notes themselves are solid. So that's how you could fold it up. And you could fold it up to a small size or roll it up. And the controls, the electronics, which would be fairly standard for all of these digital instruments, are attached onto the side. So here you can see the different features. You have your speakers, your control panel, the notepads, the playing surface, and you play it with regular steel pan playing sticks. Here's an exploded view showing the construction of it, again, which is very simple. You'd have your sensors, which are normally piezoelectric sensors or force-sensitive resistors, and they would be placed under the notepads, and the top surface will be covering the entire surface to protect the wires and whatnot inside. So this is the idea. So the first step really is to test it out and see if it has any potential. So the idea was validated by building and testing a prototype, of course. And you would see details of this first prototype that was made. We used some, materials that were available. Stainless steel sheet, we used leatherette fabric. You see a little, food container on the side there with electronics housed in it with little speakers. And we basically put together something quickly to see if the idea had any potential. Interestingly, the cost of this, to put everything together using all of these services, came up to around 2,600 TT dollars or 388 US. So we're keeping an eye on the cost here. Here you can see examples of the prototype being constructed and the way that it would fold or roll as envisioned in the final version. So it does work and it does fold up as we want it to. And then we tested this now prototype with 10 experienced STEELPAN players. Associated with UTT, we have our Academy for Performing Arts where all of our musicians and instrumentalists reside. And of course, I'm also interested in this instrument, being a musician myself. So we tested it out with players to get their feedback, and this is what they had to say. We took some ratings, 4 main ones essentially, on playing experience, functionality, size, and weight of the prototype. And you can see the scores there. Out of a scale of 5, the mean was above 4 in all of the cases, meaning that the overall experience was good, functionality was good, the size was good, the weight was good, they liked that, and the standard deviations were fairly small, indicating that the means won't spread out, the values won't spread out about the mean. So these initial results look good. So I'll wrap up now with what participants liked, what they didn't like, and the next steps. What participants liked, the players liked, the good weight, the capability of folding, the portability and ease of storage. They like the flat surface as opposed to the curved surface of the real pan and steel pan instrument, because it's easier to play than a traditional pan. It could be used as a practice pad that you could carry around. And of course, the steel pan is metal, whereas this wouldn't corrode. What participants didn't like, they weren't able to play chords given this first iteration. We used a simple Arduino controller, low cost, just a prototype. And they didn't like that the control panel was on the side, they wanted it on top. They didn't like the sound quality too much. Again, we used pretty low cost, cheap speakers. They didn't like that the size and shape of the notes were all the same. The sound of the stick hitting the pad also was deemed to be distracting in this version. Normally in steel pan playing, you'd have rolling capabilities, but again, because of lack of polyphony on the instrument, the musicians weren't able to do that. And low volume and lag in audio output, again, because of the low cost controllers we decided to use initially, the players weren't able to do this. So therefore, moving forward, new features and improvements then, well, the players wanted sounds of other steel pan types and musical instruments to be included. They wanted recording and playback facilities, separate the control panel from the body of the roll-up pan itself, an audio jack for external connections, portable playing stand would go together with this device so that they could rest it on it and tilt at various angles. Variation in the shape of the notes themselves as compared to the traditional steel pan, a little convexity, and of course, improvements in the electronic hardware. And finally, most importantly, how about owning the device and the cost that they're willing to pay? So 3 of the participants said, between 500 to 1,000 TT. 5 participants said they'd pay between 1,000, 1,500, and 2 said above 1,500 US. But we are aiming for as low cost as possible. So within maybe the $300 to $500 range for eventual manufactured device at scale. So in conclusion then, the main takeaway from this work is that we prototyped this low-cost roll-up digital steel pan to see if there was any merit in the product itself for musicians. The concept showed promise, initial promise, as a viable product once we could keep these costs low and improve the quality by sourcing components and getting custom PCBs made, etc. And finally, further testing with revised prototypes would enable us to look at different audiences for the device, such as professional musicians, students, tourists, various different market segments that may have different needs. So in summary, this is my talk. I would just like to thank the Academy for Performing Arts and also IndigiSounds, our key collaborators in this project, as we move forward. Thank you very much for your attention. At this time, I'd be happy to take any questions that you may have.
Thank you so much. Yeah, thanks for that very, very clear presentation there, Umesh. I think you probably answered most of the questions I had as you were going through the presentation. I am seeing a comment on the chat about how much people appreciate the pan, and so from an international point of view, it's got a good audience, potential audience. I've got some other questions here. Jonathan Chu would like to know, where did you get the MIDI files for the sounds? Where did you source those MIDI files from?
So for the initial version, there were some free MIDI, free sound samples on the internet. So we triggered them using MIDI, but the sound samples themselves were freely available. And currently for all other versions, we've partnered with IndigiSounds, and we are using, they have kindly donated their sound sample library for us to use for further development. Okay,
thank you. The next question is, are the pads velocity sensitive? By which I assume the question means, also from Johnny Chu, that if you hit it harder, do you get a louder sound?
That is correct. They are velocity sensitive, yes.
Okay. Who do you see as being the primary customer for this product? I might have touched on that as you went through the presentation, but just to underscore that for us.
So in terms of product development, we have various market segments. And I mean, what we're looking at is developing a platform where we could spin off different products. So first of all, you have students in schools and, learners. So for example, in my case, my children, they would play instruments and it would annoy me from time to time. So you would want them to be able to practice without sounding the instrument. So you could imagine a very low cost device where they could practice their rolling, their notes, their tunes, whatever, with headphones on. So that's one market segment. Then you have the tourism market segment. Imagine, people coming into the country for carnival. Well, I can't see that they would want to buy a traditional steel pan unless they're a musician. But you could imagine tourists wanting to buy a very low cost version of the steel pan that they could take home and play with, keep as a souvenir, etc. And then also for traditional musicians who would want like a simple MIDI controller or a practice pad to use when they're traveling around, that's a third market segment. And I assume that other market segments would become obvious to us as we continue the development. But we would like to involve users. As I said, we're developing this as musicians and together with musicians so that we hope to get buy-in as we go along.
Fantastic. So I've got a question which is about the ergonomics, because I was quite surprised to hear you say that the musicians seem to prefer the flat ergonomics to the curved ergonomics, because I was I'm not a pan player, sure, but I would have thought that the ergonomics of playing the pan is part of the whole experience. Have you got any more comments around that? You have any idea why or
sure. So if you look at music instruments on the whole, they are horrible at ergonomics in general. The guitar, for example, a lot of the instruments, they cut your fingers, the way they're designed, you have to hold them because they were initially developed as sound generating tools. But the human part of it, the performance part of it, how you play it, that's actually like a rite of passage for a player. Now, the steel pan instrument, the ergonomics follow the function initially. So if you sync a drum, it has to have that concave shape because of how it was made. But if you eliminate that constraint of having to have that concave shape, then clearly it's simpler just to hit something on a flat surface than having to arch your elbows and move around. So there are two things that play here. One is the cultural heritage of playing the pan. You'll see the players jumping around and moving their hands, which is part of it. But then there's also the ergonomic part, as you mentioned, where it would be less stress on the joints and easier if there's something flat to play. So what I would say is that, at the end of the day, musicians and consumers will have choice. And if someone is happy playing something flat and it's easier to play, good for them. If the traditionalist would like a traditional pan with a curved surface to play, then fine. But there will be options available for everybody.
Okay, great. Well, there are a couple of other questions, but unfortunately, I think we're out of time for that one.
Yes.
So
Umesh,
again,
we made a note of the additional questions, so you're going to get that on your email. And yeah, so again, that's fantastic work. I think it's appreciated by everyone here.